Hello everyone, this is Mr. 13 Things. Getting prepared now for the summer for my own daughters who unfortunately are not in 5th and 6th grade. And like many parents, I was not cognizant of how important 5th and 6th grade was for my kids, so I have to kind of go back now and work with them into what they might have, could have, should have, perhaps even had back in 5th and 6th grade, so that they can really be established for learning to apply these incredible tools that are coming out. I say this at the end of 3rd or 4th grade, perhaps 2nd grade, our kids learn 390 math facts to knowledge. Math facts to knowledge. Said math facts being 1 plus 1 and 1 times 9 and 9 divided by, 18 divided by 2. I don't think that 9 divided by 4 is a math fact. So math facts, pretty standard, and knowledge being 3 seconds. It is my belief that in addition to those math facts, the knowledge of, I'm going to draw one here, practicing slowly, of the unit circle and how it works basically, where the radius equals 1, the diameter equals 2, the area equals pi, and the angle inside equals 2 pi, and how the values change on the unit circle is something that could be considered a set of math facts. I say this, over time we start to learn, and there's some great TED Ed videos out talking about, we start to learn that 9 is not the only thing about 9, or 8 is not the only thing about 8. It can be 8, 8 dozen, 8 can look in different spots, it can be 80, it can be 0.08, so 8 takes on a lot more richness later on, but we did first learn the math facts. The math facts, or the unit circle facts, end up producing numbers that are irrational numbers, which is a thing, I think, irrational which is a fancy name for something that cannot be expressed as the ratio of 2 integers. I think that's what an irrational number is. Alright, so that said, there are radicals that come up in this unit circle and in life, and some of the radicals we end up finding are things like the square root of 2, that somehow emerges here, the square root of 3, and the square root of 5, mostly because that is involved with something called the golden ratio. So at some point in time, long before students can kind of get their arms around these repeating decimal, or these decimals that go on forever, they can understand what these lengths are, or even areas are, by looking at the concept of geometry, which they do anyway, at least in everyday math. They learn to do translations, rotations, reflections. So, going to the unit circle, let's take a look at the construction that will get us the square root of 2, the square root of 3, the square root of 5, and in fact the golden ratio. Phi. So I'm going to once again draw the unit circle, and I'm going to do an edit undo because that was such a wonderful unit circle. I'm going to try to draw the unit circle. And it jumped around because I hit the pen. I hit edit, undo. Once again, I'm going to try to draw the unit circle. Now this is where you start learning that sometimes the freeware isn't perfect, but I'm using Smooth Draw 3.0 and it does not seem to have a line tool. If anyone knows where the line tool is or the circle tool is, let me know. Though there are ways to go about doing this. We'll call this a unit circle and we're going to draw it. I'm going to change the color here for the axes. I'm going to put a red-ish for the X. And it's relatively standard nowadays in 3D CAD system. I'm going to put a green for the Y. And of course, I'll go back and I'll try to even do a little black here. Black is not going to work. I'll go back to yellow here for the radius. And on a regular basis, I'm going to do an edit undo here. That one looked too much like an axis here, so we're going to go ahead and draw the yellow here, a radius here, r equals 1. And remembering each time to get students to say the radius equals 1, the diameter equals 2, the area equals pi, and of course the angle equals 2 pi or 360 degrees is a worthwhile endeavor. Just like back in kindergarten when we say today is May 15th. The weather outside is rainy, repetitive, facts. 6 times 6 is 36, 6 times 7 is 42, repetitive facts. But on top of that, we can go and put things in a little deeper, and this is how we're going to go about doing that. We can all of a sudden take that red axis, if we could. I'm going to go here. I'm using the pen suck the color tool, and I'm going to go ahead and take that axis a little bit farther out now. And I'll try another color here. I'll put it in purple. I can draw the square root of 2. Edit, undo. I'll just do it here. The square root of 2 is the same as the distance. That distance there. So that, in fact, is the square root of 2. And if you remember, this is 1, and this is 1, and this is 90 degrees. Therefore, that becomes the square root of 2. The next construction, and I'll switch to blue for that, or cyan, you get by actually going ahead and just dividing this line to the fact into a half, so taking a distance here. And you'll see later that it's part of a larger construction, and drawing a line from the center out through there. It turns out that the distance is going to be 2, but out to the what's called the tangent line. So that point there. This distance here is the square root of 3. This turns out to be 2, square root of 3, and this is 1. So students, learners, adults, can learn what the square root of 2 is, what the square root of 3 is, and this last construction I'm going to do over here on a separate, basically the same construction, but it's a little bit more difficult to see. I'm going to go ahead and draw a new unit circle. Different scale, obviously, with the radius equals 1, the radius equals 1, the diameter equals 2, the area equals pi, and the angle equals 2 pi. Repetitive. Now I'll go ahead and draw this box with, in fact, its divisor there. I'm going to draw now a radius that swings out here and draw that line through until you get that line there. I'll do that back, edit, undo. Try to do a little bit better job here. and I will do this next in geodometer. I'm sorry, not geodometer. I will do it in Geometer Sketchpad and GeoGebra. I'm not sure what we do with 5th graders when it comes to using compasses, like not compass like in the woods, but compass stick your buddy. But if we have this construction, we now have, in fact, a distance 1 here. That distance here, so this distance from there out to there, remember drawing the box, the square box, the square of 1, the unit box if you would, taking halfway, swinging an arc, which is part of a circle. We have a value there, which is equal to phi, and this value, if you take the 1 through phi out to the tangent line here, this here is the square root of 5. Later on, you're going to see that this emerges from the Fibonacci series. Fibonacci series. It's the ratio of any two values in the Fibonacci series out past the 13th, 14th. So essentially, you're going to see it turns out to be, in best case, one of the nice ones is 144. 233, 377, 610. So this value turns out to be 610 over 377. But really that value is also really the average of 1 and the square root of 5. So by going through this construction with the unit circle a number of times repetitively, until these numbers become knowledge and these constructions become knowledge, when you go to this, which is the unit circle and all of its mysteries and numbers, where things like the square root of 3 over 2 emerge, or the square root of 2 over 2, or whatever the case may be, they're not struggling with the concept of what are the values. They're just getting, in fact, what are the trends. Thanks for listening.